This is SpaceTime, Series 29, Episode 59, for broadcast on the 18th of May 2026. Coming up on SpaceTime, a black hole flare explodes in the heart of our galaxy, trying to explain one of the mysteries of Snowball Earth, and the legacy of Australia's SkyMapper survey so far. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have observed a dramatic mid-infrared flare erupting from Sagittarius A star, the supermassive black hole at the centre of our galaxy. The discovery, reported on the pre-press physics website archive.org, follows 20 years of searching for just such an event. Sagittarius A star is located some 27,000 light-years away at the very heart of the galaxy, and it has some 4.3 million times the mass of our Sun. This new detection was made by the Webb Space Telescope, which is exquisitely sensitive to mid-infrared events. Webb's observations show that the blast lasted some 40 minutes, and its implications could fundamentally transform science's understanding of black hole behaviour and the violent magnetic environments just outside their event horizons. The event horizon is the point of no return around a black hole beyond which matter falls forever into the black hole singularity, a point of infinite density and zero volume where science's understanding of the laws of physics, space and time break down. While Sagittarius A star has been seen flaring before, recorded in radio waves, near-infrared and X-ray frequencies, the mid-infrared window has remained stubbornly dark until now. And so this new observation finally completes the long-sought-after supermassive black hole's multi-wavelength portrait. Astronomers think the flare was triggered by something called magnetic reconnection. This involves intensely tangled magnetic field lines near the black hole suddenly realigning, snapping and then reconnecting, unleashing a massive pulse of energy in the process. And that energy accelerated electrons to relativistic speeds, which then emitted synchrotron radiation as they whipped around the reconfigured magnetic fields. This new observation has allowed astronomers to see the event unfold in real time, revealing the unmistakable spectral fingerprint of synchrotron radiation cooling as the high-energy electrons bled away energy through radiation. These new observations will allow astronomers to better directly probe and measure the black hole's magnetic field strength near the event horizon with unprecedented detail, to develop a better understanding of how supermassive black holes devour matter, ignite sudden outbursts, and exert their gravitational and magnetic dominance over entire galaxies. This is SpaceTime. Still to come, a new explanation for some of the unsolved riddles about Snowball Earth, and we look at the legacy so far of Australia's SkyMapper project. All that and more still to come on SpaceTime. Scientists have developed a new explanation for one of Earth's great climatic puzzles: how a Snowball Earth event, known as the Sturdian glaciation, could have lasted as long as it did. The research, published in the Proceedings of the National Academy of Sciences, suggests that rather than a single 57 million year long unbroken Snowball Earth state, the Sturdian glaciation may have seen the planet oscillate between fully ice-covered conditions and more ice-free states. As the name suggests, Snowball Earth events occur when our planet is almost completely covered in snow and ice. The exact reasons for this are still under active debate, although plate tectonics and changes in Earth's orbit and axial tilt are thought to have played at least a part in these dramatic climatic change events. Scientists generally agree on two major Snowball Earth periods. These were the Sturdian glaciation, which went from around 717 to 660 million years ago, and the Maranoan glaciation from around 650 to 635 million years ago. Some scientists suggest there may well have been a third earlier glaciation event known as the Maganini glaciation, which occurred around 2.2 billion years ago. However, the exact length and intensity of all these events remains uncertain. And the 56 million year duration of the Sturtian glaciation during Earth's Cryogean period is especially problematic as it challenges some climate models. The study's lead author, Charlotte Minsky from Harvard University, says this was a time which predates the age of the dinosaurs and most complex life forms. Minsky and colleagues used a coupled model of the ancient climate and the global carbon cycle to show that the Earth may not have been locked in a single unbroken snowball Earth state or period when the entire planet was frozen over. Instead, they proposed the planet likely oscillated between fully ice-covered snowball conditions and more ice-free hothouse intervals throughout the Sturtian period. The author's simulations suggest that intense weathering of basalt in the Franklin Large Igneous Province, a vast volcanic region located in northern Canada, believed to have erupted just before the onset of the Sturtian glaciation, may have drawn down atmospheric carbon dioxide, a greenhouse gas, and it removed enough of it from the atmosphere to trigger multiple global glaciations. As volcanoes and other processes slowly rebuild atmospheric carbon dioxide, the climate warmed again and the ice retreated, and large areas of fresh basalt were again exposed to the atmosphere. The renewed breakdown from weathering then pulled carbon dioxide back down, pushing the climate into another snowball phase. The authors argue that this repeating cycle of carbon dioxide-driven freezing and thawing could naturally sustain glacial interglacial swings over tens of millions of years. The mechanisms revealed by this study resolve several long-standing paradoxes, most noticeably the previously inexplicable length of the Sturtian when compared with physical climate models. The study also matches observed sedimentary patterns from that time period, and it explains how atmospheric oxygen levels could have remained stable despite extreme climate upheavals. The study suggests that repeated returns to warmer ice-free conditions may have helped prevent a complete collapse of atmospheric oxygen. And Minsky says this could help explain how aerobic life persisted through such an extreme period. This is SpaceTime. Still to come, we look back at the legacy so far of Australia's SkyMapper Southern Survey. And later in the science report, paleontologists discover fossils of a new type of plant-eating dinosaur in Thailand. All that and more still to come on SpaceTime. It was almost exactly 10 years ago that the Australian National University SkyMapper telescope released an initial 18 terabytes of observations of the southern skies. The data was the first of more than 2 petabytes of raw and calibrated information that has helped change forever science's understanding of the cosmos and our place in it. By the time of its fourth and most recent data release, the SkyMapper Southern Survey had covered more than half the sky, generating some 400,000 images, showing 700 million objects and achieving 15 billion detections. SkyMapper is a wide-field survey telescope located at the Siding Spring Observatory in far western New South Wales. The observatory's director, Christian Wolfe, says SkyMapper's unprecedented images and measurements are creating the first comprehensive digital survey of the entire southern sky. He says the end result will be a massively detailed record of more than 1 billion stars and galaxies, all to a sensitivity of 1 million times fainter than what the human eye can see.
Yes, we've been looking for quasars, especially quasars at high redshift in the early universe, for quite a while now. SkyMapper is a bit late to that game because a lot of quasars in the early universe have been found by the Sloan Digital Sky Survey, or the Northern Sky, and SkyMapper is the first survey that really goes to similar depth studying the southern skies. But really what we want to do is push the envelope and really get good demographics of the fastest growing and most massive black holes in the universe. What we also can do is quasars are supposed to be at really, really large distances, and especially when we believe they are in the early universe, then they're not supposed to move at all, as opposed to the foreground stars of our own Milky Way. And so we were able to read out our candidate list, we're trying to look for these high redshift quasars, and then because their colors are similar to cool stars in our own galaxy, our lists of possible high redshift quasars are polluted with vast amounts of Milky Way stars that we're not really interested in. And when we want to know what a particular object is, we have to point a spectrograph at it, at a somewhat bigger telescope, and then we have to check them off one by one. So what is this exactly? Is this a star now? Take the spectrum. A star. This one over here, is that? Let's take a spectrum, another star, and so on. And you can't afford to go through all of them because there would be millions of candidates. So really, Gaia has helped us to weed out a lot of this contamination by Milky Way's foreground stars. It doesn't completely remove that. We still find stars among our candidates, but at least it's now become realistic to find these very rare and very fast-growing, very bright quasars. Our work right here with the SkyMapper telescope focuses on getting the big guys, the monsters, and we believe that they have been largely overlooked. In fact, anytime someone has discovered the now brightest or now fastest growing black hole, they've been saying, wait a minute, we've had this on our candidate lists forever. We thought this was a star. We were pretty sure this was a star. We didn't even look at it in detail because it was so unlikely to actually be a quasar. When you look at very faint objects, you get a number of quasars among the stars, but as you go to brighter and brighter ones, quasars become rapidly rarer up to the point where you think, well, we haven't seen anyone brighter than this one, so, you know, they are probably pretty rare. So everything you then see at that brightness, you think must be a star anyway. So we have this kind of biased view that the brightest ones are most likely stars, so we don't go after them because we don't enjoy taking spectra of 1,000 stars only to learn that there wasn't a single black hole or quasar among them. We probably don't even get the time at telescopes awarded for that, just because it's such an unlikely to be successful undertaking. And this is why we have missed the monsters, the rare monsters out there, but that's what we are setting out to correct now. So by combining Gaia, they weed out a lot of the candidates from the candidate list with Taipan that can take still so many spectra of objects, most of which are not going to be quasars. We can actually afford to attempt to get the complete demographics of bright quasars in the early universe and therefore map out the growth of black holes with time in the early epochs.
With the SkyMapper data online and being available for everyone to see, that's got to be a tremendous boost for astronomy generally. I think it's, developing something like 2 petabytes of data, studying the southern sky 36 times, 600,000 images, something like that?
Yes, that's the right order of magnitude indeed. And fortunately, the SkyMapper project was intended to start 10 years earlier, but the first prototype of the SkyMapper system that was actually at Mount Stromlo, just outside of Canberra, was burned down in the early bushfires of January 2003. And then it took a while to build a brand new SkyMapper, which then was, of course, put at Siding Spring Observatory.
Yeah, it's bushfires a few years ago.
Which also, almost precisely on the 10th anniversary of the Stromlo bushfires, the Siding Spring bushfires happened, and SkyMapper was about ready to start its survey and was inundated in ash, and it took 4 months of cleaning of the optics and mechanics and everything to get it back to where we wanted it. And we actually did lose some kit in the process, some little kit. But anyway, so in some ways we are fortunate because the capacity of computers and disks and so on has improved a great deal over time. So now we can actually do it for a reasonable cost. We offer our data online over the internet. Everyone can access it, scientists, teachers, the interested public who just wants to have a look. SkyMapper has several color filters, 6 of them, that cover the color range from the near ultraviolet, which the human eye just about cannot see anymore, through the visual that the eye sees very well, to a couple bands in the near infrared that again the eye just about can't see anymore. And stars show usually typical color patterns, but the exact pattern depends on how many absorption lines are in the spectrum. And most stars in the Milky Way have quite a lot of these absorption lines and have really areas where the absorption lines are heavily affecting the colors. And when you get something like a nearly perfect rainbow, then you know, oh, we have a metal-poor star. That's what we call it, a star with few heavy elements, a star with few absorption lines. And so we're selecting these stars based on their color, and then again we need to go to a bigger telescope and take some more refined measurements, measure the spectrum indeed, and see what we've got. How metal poor is it? How chemically pristine? On the one hand, we really look for thousands of these metal poor stars, which are from the first generation of stars formed in our Milky Way galaxy around about 13 billion years ago.
These will be population 2 stars?
Yeah, these are population 2 stars, and these are actually extreme population 2 stars, not just average population 2
ones
stars.
made out of the ones that actually were formed from those population 3s.
That's right. That's right. I mean, the term population 2 star still covers a couple billion years of time in the formation history of the Milky Way, and we are essentially pushing towards the early limits of that period, and we aim to find several thousand of these very metal-poor population 2 stars to learn what the Milky Way really looked like at these early ages, and then, of course, finding the most chemically pristine one, going after the record here and seeing what's possible out there, what has still survived until today. That's of course a big part of it, and maybe one day we find an even more pristine one than this one that was found in 2014.
That's Dr. Christian Wolf, the director of the Siding Spring Observatory. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that obesity trends are now rising faster in low and middle income countries, but at the same time they've started to level off in many high income nations. The findings, reported in the journal Nature, looked at data from 232 million people across 200 countries and territories over the past 45 years. The authors found that obesity rates increased over the study period, but trends have varied in different populations. For high-income countries like Australia and the United States, the rates went up at the start of the measuring period, but have since plateaued. Now, in comparison, the rise in obesity rates in low and middle-income countries has risen sharply, now encompassing some 30 to 40% of all adults. A new study warns that a key Atlantic Ocean current system that helps regulate the planet's climate could weaken more than expected by the year 2100. The findings, reported in the journal Science Advances, claims the collapse of the Atlantic meridional overturning circulation, which powers things like the Gulf Stream, would have devastating consequences worldwide. This conveyor belt of currents plays a crucial role in redistributing heat by transporting warmer waters from the tropics northward. The weakening of the Gulf Stream would cause harsher winters in northern Europe, droughts in South Asia and the Sahel region of Africa, and higher sea levels in North America. Previous climate model predictions estimated an average slowdown of around 32% by the end of the century due to climate change. But the new research estimates that the system could slow by as much as 51% by the year 2100, under a mid-range scenario for greenhouse gas emissions with a margin of error of plus or minus 8 percentage points. Paleontologists have uncovered a new type of plant-eating dinosaur, the largest ever found in Southeast Asia. The discovery, published in the journal Scientific Reports, was made at a dig site at the edge of a pond in northeastern Thailand 10 years ago. The fossils were found in strata dating back to the early Cretaceous period between 100 and 120 million years ago. The new sauropod dinosaur, named the Gartienchioneumensis, is based on analysis of spine, rib, pelvic and leg bones, including one front leg bone 1.78 metres long. That's as tall as a human. Sauropods are those dinosaurs with elephant-like bodies and feet, a long neck and small head at one end, and a long tail at the other, sort of like Fred Flintstone's pet Dino. The authors believe this new sauropod species would have weighed around 27 tons as an adult. That's about the same as 9 elephants, and it would have measured some 27 metres long. Professor Steve Novella from Yale University, president of the New England Skeptical Society and a fellow of the Committee for Skeptical Inquiry, has written a paper looking at the broader problem of pseudo-archaeology and those everything you've been told about history is a complete lie conspiracy theories, which spread like wildfire through social media. The Skeptic's Tim Mendham says Novella points out that engaging on social media to discuss pseudoscience can be exhausting, and that you need to keep reminding yourself that what you're seeing isn't necessarily representative, but it's only the loudest and most extreme voices that tend to get amplified.
Pseudo-science, pseudo-archaeology, where people sort of claim, obviously the things like von Daniken, who claimed that we had to get help to build all these ancient civilizations, that the ancient people were obviously not good enough or not clever enough to build these, so we bring in extraterrestrials to do it for us, or they recreate a phony history and a phony civilization. One of them he's particularly looking at is the ancient civilization of Tartaria, which is sort of doesn't exist. No such thing.
It's an Indian car, isn't it?
It's taken the word from Tartars, from the Mongols who invaded into Europe. This is one example of people who are saying, look at all these buildings here. These people couldn't have built them. Interesting thing, they're talking about 17th century, 18th century buildings, but there's a lot of records of these buildings being built, not by ancient civilizations, but by stonemasons and people like that are very much in the time. The trouble is, a lot of this pseudo-archaeology is heavily racist-based, that third world countries, be it Africans, Egyptians, Central Americans, whatever, could not have done this because they're basically inferior people and they needed aliens / white people to do it for them.
Now, we all know aliens are either green or grey.
No, I'm not talking about the aliens being white. I'm talking about the people who build the civilization, supposedly. And there is a lot of that in there. There's a lot of sort of end of the world, new world order. It is quite openly racist, some of it, about that we built them, you couldn't build them because you're not very good enough. There's all sorts of examples of this. We've had articles in Skeptics magazines about the history of pseudo-archaeology. It was particularly strong in the 1800s in America, of course. There were a lot of people who were claiming they're finding the golden city, etc., rewriting history. Von Daniken, more recently, Eric von Daniken, who wrote the Chariots of the Gods stuff, which was not original at the time, but he made a lot of money out of it. Rewriting history, rewriting the same way that he's saying you couldn't have done this because you're a lowly third world country civilization like the Mayans or the Egyptians, etc., that you had to have help. And von Daniken was saying it's aliens. Others might say it's a special civilization from Tartaria. And it's an annoying thing. It's an anti-science thing. Steve obviously sees it as indicative of a stronger anti-science philosophy. Pseudo-archaeology is just one example of where it's applied. It's a problem. It's a problem. And in the world of social media, etc., these pseudo-scientific claims can spread quickly rather than by a paperback book or something like that, and it becomes an important issue from a science point of view. And he stresses at the end of his article, scholars and scientists need to engage with the world much more than they currently do. We cannot simply ignore the nonsense with the idea that it will shrivel and die if we don't give it light. That is such a pre-social media idea, if it were ever true. We have to fight for scholarship or logic, facts and evidence. We have to fight for history. I thoroughly endorse that, absolutely 100%. And
well, we're seeing it in today's world, aren't we?
It is a sad thing that we're seeing this, especially now. It's always the case. Don't criticise pseudoscience things because it only gives them air. Well, they've already got the air. They don't have any trouble finding air. No, you have to criticise them. You have to come out and be open about it. It won't just shrivel and die. In fact, it'll do the opposite. So therefore, whether it's ancient history, archaeology, pseudo-archaeology, pseudo-medicine, pseudo-science generally, anti-science, you've got to speak up.
That's the Skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.